Although we're not sure when we're getting the 5090, nVidia made an announcement today quietly that I think is monumental for progress in open source and open LLMs. Today, nVidia released a new version of Llama 3.1 Nemotron. And of course, this model has been released for a number of weeks, and it was impressive when they released it. But this model is something different. This is, at least based on current benchmarks, this is an open weight model that, based on current benchmarks, actually outperforms GPT-4 Turbo, Lightning, and most importantly, Claude 3.5 Sonnet in coding and mathematics benchmarks, which is completely insane. And it's only a 70 billion parameter instruct model, so it's not something that is entirely out of the question for most people to run. So what did nVidia actually do to make this possible? And is this model actually better than GPT-4 Omni and Sonnet 3.5? I want to unpack this and then show you guys how powerful this model actually is. And one reason that I'm so impressed by this is I hooked this up to Cursor and started using it, and I had to double check that I had actually disconnected my Anthropic API key because this model was so good. So let's jump into more of the details about this model. Welcome to AI Flux. Let's get into it. So nVidia has just released a fine-tuned version of Llama 3.1 70B under the name Nemotron. And they've used this name before, but this latest model version is something entirely different. This model has been released by NVIDIA's AI teams, and what's interesting is the different techniques that they used and how commonplace these techniques are, and more importantly, the performance gains they were able to extract with what seemingly was just another instruct tune of Llama 3.1 70B. And this instruct based on a novel approach was basically combining the strength of Bradley-Terry and steer-LM regression reward modeling, which is effectively just a more complex and advanced version of RLHF. Currently, this model beats every model, including GPT-4, Omni, and Sonnet 3.5 in the reward bench benchmark, and also shows incredible results in other areas. And again, it's stunning this was done with RLHF because for the longest time, we thought that RLHF was something that actually broke models and degraded them over time, not actually giving us kind of a cumulative benefit. And it's really interesting to see that an older form of Llama 3, Llama 3.1, was the model they chose. So I think RLHF got a really bad name because OpenAI tried to use it for things it wasn't really meant to do. The reason that sometimes this works well, and the reason that tools like Midjourney use this, is they're correcting the outputs of prompts to things that people like to see or that people give a better score on when they see it. And of course, this is wildly simplifying what RLHF is. But at the end of the day, LLMs are still only generally used by humans. That might change with agentic workflows, but for the time being, end users are mostly humans. And the only way to measure usefulness is effectively by human standards. Because what good is the output if it's ASI level, but not actually interpretable by a human? So basically meaning if it can pass MLU with an incredible score, but not actually be interpreted by a human. And the other thing that really surprised me about this is that Nemotron 8B is not even close to as powerful as this latest model from NVIDIA. And if anything, this just shows that NVIDIA's whole strategy of creating and releasing incredible open weight models is really working quite well. So what benchmarks are they actually talking about? So specifically, they're looking at Arena Hard, Alpaca Eval 2, and MT Bench, and then of course with Reward Bench. But the biggest sort of advancements are shown in these three benchmarks. So Nemotron scores 85, Sonnet 3.5 scores 79.2. In Alpaca Eval, Nemotron is scoring 57.6, while 3.5 is scoring 52.4. It's important to note that the degree of increase is closer between GPT-4 Omni and Nemotron, and I would really wonder what these benchmarks are really focusing on. For me, MT Bench is one of the better benchmarks in terms of when I've used models that have scored well with MT Bench, they appear to be smarter and just more useful. For me, MLU is one of the least useful, although it's very generalized. MLU, I've used models that have scored really well there that basically have very little value for common use. Now, the thing is, we're gonna have to wait to see how this does in LMSys and how it actually does with people using it. Because if we've learned anything from reviewing these models, or if I've learned anything from looking at these models, you really never know until they've been out for a few days and people have actually sort of kicked the tires fully. Sure, they're impressive, but sometimes these things can get a little out of whack. But let's take a quick look at the Hugging Face page to see a bit more of what NVIDIA did to make this model so powerful. And what's interesting is the reason they picked these three benchmarks, which is maybe a little bit shady, is they say here that this model reaches arena hard of 85, alpaca eval of 57.6, and the GPT-4 turbo empty bench of 8.98, which are known to be predictive, keyword predictive, of LMSys chatbot arena elo scores. So they're kind of front running this by saying, look, it did really well on all these 3 specific models, and in theory, it should give us a very good score on these others as well. They're also touting that as of October 1, this model is #1 on all 3 automatic alignment benchmarks, edging out frontier models such as GPT-4 Omni and Claude 3.5 Sonnet. And granted, GPT-4 Omni, it's hard to say that that's necessarily a frontier model still with the release of o1, but obviously that's OpenAI's kind of most general model currently. And they give us a few more details of what kind of RLHF they use. So they mention here that they used reinforce specifically as a form of RLHF, and they started with Llama 3.1 Nemotron 7B reward, and help to steer preference prompts on Llama 3.1 instruct were used as kind of the initial policy to gate what was good and what was bad in terms of improving this model a little bit more. And you can also run this right now on NVIDIA's interface. I'm going to be doing that in just a few minutes. So the big one is that it passed the strawberry test. And the funny thing is that the strawberry test is so widely known now, it's likely this has just ended up in training data sets. So it is cool that it was able to do this, because this is actually something that o1 for the longest time couldn't do, and sometimes will actually still fail in terms of just losing focus. If anything, using this model, what I've noticed the most is it retains focus and consistency much better than even other Llama models that I've used. And in some ways, I think consistency in reasoning and consistency in understanding input and how you've interacted iteratively kind of past like 10 back and forths, in my opinion, is more impressive than like 0-shot prompting a snake game or 0-shot prompting some kind of programming task. They have some further evaluation numbers here, but this is basically what we just went over. What's also cool with the NVIDIA NeMo framework is that these can leverage NVIDIA TRT LLM right out of the gate, which means that if you have enough RAM, so for instance, if you have at least 4 40 gig GPUs or 2 80 gig GPUs and 150 gigs of SSD space, you can start running this right away. Which is cool, but I fully acknowledge that I don't really have that kind of hardware at my own home, and I don't really have the money to rent that currently. But NVIDIA's MVCR platform is pretty cool, and I like this because it makes using these models much faster, and it means that when you deploy these on expensive hardware, you're not wasting a lot of time on that hardware waiting for stuff to kind of spin up and get going. So now that we've gone over kind of why this model is so interesting and why these benchmark numbers are really, really curious, let's get into actually using it a bit. So I've sent in a few kind of test benchmarks here, and it's done pretty well. But now I'm going to reset this, and we're going to do some actual coding in this format here. I might do a stream later with Cursor, but let's see what we can get through here. So I'm going to say, help me write a basic React app. I would like this to be an SPA that tracks state across each individual tab. The purpose of this app is to dispatch machine IDs tied to a secondary label on each package. So I'm not giving it too much information. We're keeping it a little bit vague. And I said I want a React app. It needs to be an SPA. There is some sense of how I want it to manage state, and then a rough description of how this is being used. So we'll see what this gives us. So this is the result I got with this model, and it's pretty interesting. So this is my prompt asking for this kind of SPA React app, and the code it gave me was pretty interesting. So it says, here is the basic React app that meets your requirements. There is 1 tab for tracking, 1 tab for dispatching, and 1 to track their state, keeping track of machine IDs tied to a secondary label on each package as well. So they first dictate using kind of the default React router DOM library. There are a number of these you can use now, so that's pretty interesting. They name it aptly, call some pretty basic APIs here, and the code almost works. The one thing it missed here, and this is probably my fault for not prompting it specifically enough, but it did understand that I actually wanted to create labels, not just track them here. But what's cool is it's using use state, so it clearly understands how to use components, handle dispatch, and handle select package. They're also the right syntax to use in terms of structuring the JavaScript, so it actually is easy to read. It also is going file by file and naming things sensibly. This is something that previously I mostly thought was only something that Claude 3.5 Sonnet could do. And it's cool that this is still pretty aware of a number of different files and how they're actually interacting. So it gives us all of this. We have all the components here. It gives us input for our own labels. The one thing that's not in here is how it's actually capturing those, so with like a label scanner or something like that. But this is really impressive. And when I brought all of these into Cursor, they worked just fine. And we actually got an app that built on the first shot. And then when I prompted it saying, no, I'd like to use the UPS API to generate labels, it understood and made the appropriate changes that were actually pretty accurate on the first go. This is something that even Claude 3.5 Sonnet occasionally struggles with. And I found that on Cursor, even using Claude, it still struggles based on how big the context window is. So effectively, if you provide context as individual files, I'd say at least less than 8 files, the results you get are generally much better than if you just reason on like an entire project. And that's one thing I haven't been able to try with this new Nemotron fork just yet. But yeah, it made these changes. We do at the end have an SPA app, and this is something that even GPT-4 Omni really struggles with. Before I actually had a Sonnet API key, there was one time where our intern just started using GPT-4 Omni for tasks we'd been having him use Cloud for. And the funny thing is, he was like, yeah, this is completely useless. Like I can't really do complex coding with this. He said, specific functions or just components, that's fine. But in terms of understanding how to actually format a page, especially using JSX, was completely not functional. And being able to do JSX and then tie that into other kind of backend code is something that this model is also quite good at, which really surprised me because previously I had not encountered OpenAI models that were able to do that for whatever reason. So they'll probably fill in that niche at some point, but this model was really impressive. I'm not necessarily convinced yet though. We need to wait for more LM-SIS benchmarks. I want to mess around with this a bit more with kind of the coding that I do locally with Cursor and otherwise. And otherwise, this is going to be really, really interesting. The one drawback here is this is a pretty heavy model. So to run it locally is either going to be slow or you're going to need just a ton of GPUs. And I'm working with potentially a new GPU sponsor. So we might be able to do some pretty cool stuff, fine tuning or modifying this model, maybe attempting to get quants out of this to see if they actually map better than previous quants or previous smaller versions of Nemotron. So I'm curious what you guys think. Are you going to actually see if this is better than Claude 3.5 Sonnet? Do you think it's actually more performant, or are you kind of questioning if NVIDIA is just picking numbers that make sense so it looks like their open models are doing better than closed source AI currently, obviously running on NVIDIA GPUs? Do you like NVIDIA? Do you not like NVIDIA? Please let me know everything about this in the comments below. It's always an interesting read. And as always, I hope you guys learned something from this video. And if you like our content, please like, subscribe, and share. And we'll see you in the next one.